Hi there. Hope you have a fantastic day today. This lesson, I will go through 2023 HSC paper with you. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question number 11. So we know that I, that is first term, is 3. And the common difference is term 2 minus term 1. So 7 minus 3 is 4. And we know that Tn is I plus n minus 1d. And we need to find the 15th term. So T15. And we know that I is 3 and 15 minus 1, and we times by the common difference, that is d, is 4. So that will give me, so just go 3 plus 15 minus 1 is 14, and we just times by 4. So there you go, 59. There you go. Question 12. So we need to show that the expected value is equal to 2. And we know that the expected value is equal to the sum of the score, that is x, times its probability. So that will give me, so x is 0 times 0, give me 0. And 1 times 0.3 is 0.3. And we add 2 times a half, so that give me 1. And 3 times 0.1, we add 0.3. And 4 times 0.1, so give me 0.4. So that will give me, so just go 0.3, we add 1, add 0.3, add 0.4. So there you go. The answer is 2. Part B. So we need to find the standard deviations for these probability distributions. So first of all, we know that for the variance, because standard deviations is the square root of the variance. So the formula given is expected value of x squared, and we minus the mean square. And we know that the expected value of x is sum of x times its probability. So therefore, expected value of x squared, that will give me the sum of x squared times its probability. Okay, and we know that the mean, the expected value, is 2 here. Okay, so we just minus u squared. U squared means 2 squared. Keep that in mind. So now let me just work this out. So from this, for 0 squared times 0 will give me 0. And then we add, I'm just working out this first. And we minus u squared at the end. So now the next one is 1 squared times 0.3. Let me just write this down. Okay, 1 squared times 0.3. And we add 2 squared times 0.5, which is 4 times 0.5. And then we add 3 squared times 0.1. So we add 3 squared is 9 times 0.1. And then we add 4 squared times 0.1. So 4 squared is 16 times 0.1. So that is expected value of x squared. And then we minus u squared. And u squared is 2. So therefore we minus 2 squared. So that is 4. So that will give me, so I just put on a calculator and I just go 0 plus 1 squared times 0.3 is 0.3. We add 4 times a half is 2. So we just add 2. Then we add 0.1 times 9 is 0.9. And we add 6 times 0.1 is 1.6. So add 1.6. And we go minus 4. So there you go, 0.8. 0.8. So therefore, the standard deviation is the square root of the variance of x. So standard deviations is equal to square root of 0.8. So therefore, the standard deviation is And I just go square root answer. So there you go, 0.894 and so on. So we just need to round up to one decimal place. So the answer is 0.9. So 0.9. So there you go. Question 13. So find an expression for P of t. So P of t is the integrations of dp dt. So therefore, P of t is the integrations of dp dt. So that is 3000 e to the 2t respect to t. So now remember, if we integrate exponential, we differentiate this first. That give me 2. So therefore, 3000 e to the 2t over 2. So that will give me 3000 e to the 2t divided by 2. And we add a constant, of course. And then half of 3000 is 1500. So that will give me 1500 e to the 2t, add a c. But then we know that when t is 0, p is 4000. So therefore, 4000 is equal to 1500 e to the 0, because 2 times 0 is 0, add a c. And that will give me 4000 is equal to e to 0 is 1, and 1500 times 1 is 1500. Add a c. So therefore, c is equal to, so we just go 4000 minus 1500. So 4000 minus 1000 is 3000. 3000 minus 500, so 2500. Of course, you can just put on a calculator. So now, therefore, PT is 1500 e to the 2t, we plus 2500. So there you go. Question 14. So we need to find the equations of the tangent at the curve at point 0,1. To work this out, we're going to follow 3 steps. And the first step is we need to find the point, and it's already given. So 0,1. Then second step is we need to find the gradient at x equal 0 or 0.01. And let me just differentiate this first. So y dash is equal, we use power angle trick. So we differentiate the power. So the 3 bring down. So that becomes 3, 2x plus 1, and 3 minus 1 is 2. The power done. Then we differentiate the angle that is inside. So differentiate 2x plus 1, give me 2. So we just times by 2. And of course, no trick. So we stop here for now. That's it. So we just simplify this. So 2 times 3 is 6. So the answer is 6, 2x plus 1 power 2. So there you go. So we need to find the gradient at 0, 1, first of all. So 0, 1. So that means y dash equal, when x is 0, so 2 times 0 will give me 0. And then 0 plus 1 is 1. So 1 square is 1. So that is 6 times 1. Otherwise, you can just substitute 2 times 1 plus 1 bracket power of 2 and put on a calculator, and you should get the same answer. So that will give me 6, right? So now m is 6. So we use this formula here. Y minus y1 is m, x minus x1. So keep that in mind. So we go y minus y1 is m, x minus x1. So at point 0,1, the gradient is 6. So y minus 1, because it's 0 at point 0,1. When x is 0, y equal 1. So m is 6, and then x minus 0. And I just remove the brackets. So that give me y minus 1 is equal to 6x. And I move the negative 1 on this side, so it becomes 6x plus 1. So therefore, the gradient of the tangent is 6x plus 1. So there you go. Question 15. So first of all, we know that Mickey wants to save $450,000 over 10 years. And we know that the interest rate is 6% per year per annum and compounded annually. So R is stay the same. So that is 6%. And how much should Mickey contribute each year? So to work it out, first of all, we know the table is the annuity of $1. And we know that is for 10 years. So N is 10. So therefore, the future value for annuity of $1 is this. So let me just write this down. So that means annuity of $1 is $13.181. So in another word, if Mickey put $1 each year for 10 years, that means the future value will be $13.181. Okay, so keep that in mind. So now to work it out, we just go, the future value is 450,000. So we just need to work out from here to here how many times. So I just go 450,123, we divide it by 13.181. So there you go. So the answer is 34,140 because we round up to nearest dollar. So 34140. So 34140. So therefore, $34,140 each year. There you go. Part B. Instead, Mickey decides to contribute $8,535 every 3 months for 10 years to an annuity paying 6% per annum compounded quarterly. So therefore, the interest rate 6%, because it compounded quarterly, we just need to divide this by 4. So 6 divided by 4 is 1.5%. And the end is 10. Of course, 1 year he deposits 4 times. So N is 4, and then for 1 year, and for 10 years, you times by 10. So that means 40. N is 40. So we need to just look at the table first. So for 40 N, and interest rate is 1.5. So interest rate is 1.5. And for 40, so this go down, N is 40. So there you go. 54268. Let me write this down first. So the annuity of $1 will give me $54.268. Just double check. 268. Yep, that's right. And of course, we need to work out his future value for 10 years. So to work out for 10 years, and we know that his contribution is this much. So the contribution instead of dollar now is $8,535. And we need to go from here to here. And then from here to here, we do the same thing, because from 1 to 8,535. So on the right hand side, we'll do exactly the same. So we times by 8,535. So that will give me 542.68, which is times by 8,535. So there you go. $463,177.38. So let me just write this down. So 463,177.38. So therefore, at the end of 10 years, Mickey will have $463,177.38. So there you go. So we need to work out the perimeter of IPQCD. So in another word, we need to find the perimeter of this. That's what it meant. Okay, so keep that in mind. So to work this out, so what we do, we need to work out the length of these two. And these two is exactly the same as this, but we minus this bit out. Okay, keep that in mind. So that is the length of PQ. So let me just work out the length of PQ first. Okay, so let me just write on here. The length of PQ is, we use cosine rule. C squared is A squared plus B squared minus 2AB cos of angle in between, that is C. So that means PQ is equal to 2.1 square, and A and B are the same because they're both radius of a circle. So plus 2.1 square minus 2 times AB. So 2.1 times 2.1. And cos of the angle in between, that is 110 degrees. So that will give me, of course, this is square. Okay, don't forget. So I just go 2.1 square. We add 2.1 square. We minus 2 times 2.1 times 2.1. Cos of the angle in between, 110. So there you go. 11.8366 and so on. So let me just write down 11.86, and of course PQ is square root of that. So PQ is equal to, so just go square root, answer. So there you go. Let me just store this into memory A first. Answer, shift, store A, because I'm going to use this later. So I just write 3.44 for now, meters. So now we just go this length here, we times 2, and then we minus this part out. So it will give me this length, and this length. Okay, keep that in mind. Now we need to find the arc length of PQ. So we need to work out this length because the perimeter is this plus this plus this plus the arc length and plus this. So don't forget. So work out the arc length. So let me just write this down. The rule is this: the arc length of PQ is r theta, and the angle theta must be in radian. And we know that 110 degrees to convert to radian, which is times by pi over 180. So 110 times pi over 180, that cancel out. So that is same as 11 pi over 18. So the radius is 2.1. So 2.1 times 1 pi, 11 pi over 18. That will give me, so I just go 2.1 times 11 pi over 18. So there you go. Let me go answer, shift, store in B first. Okay, so 4.03. So 4.03. So that's the answer. Let's just write meters first. So now we just add them up. So don't forget, okay, this length here, if I times 2 minus this length out, will give me this length. Okay, keep that in mind. So let me just write this down for you first. So the perimeter is equal to, so 8 times 2, and then we minus the length PQ, that is this 3.44 minus 3.44. So that will give me this length here. Let me clear this first. So that so far is this length that we add. Now let me add this. So we add arc length, so 4.03, and that will give me this so far. Then don't forget we add this length, 2 lots of 3.6. Okay, keep that in mind. So we just go add 2 times 3.6. So that should give me, so I just go 16 because 8 times 2 is 16 minus the length PQ I store in memory A. So I just go minus A, and then we plus the last one I did, the arc length, that is alpha B, and we add 2 times 3.6. 2 times 3.6. So there you go, 23.79. But then we round up to 1 decimal place, so 23.8. 23.8 meters. So there you go. Question 17. So we know that if we integrate f dash x, f of x power n dx, that will give me 1 over n plus 1 f of x power n plus 1, and add a c, of course. So now if you think about it, if I differentiate inside here, that will give me 2x. But we have x in front, so therefore to make it 2x, so I can just times 2 here, then I divide by 2. Okay, keep that in mind. Let me just rewrite this out. So that will give me a half of integration of 2x and square root of x squared plus 1. So I just write in index form. So it becomes x squared plus 1 power of a half. So x squared plus 1 power of a half dx. So now I just apply the rule. So this is n plus 1. So a half plus 1 give me 3 over 2. So let me write this down. That become a half. And then 1 over 3 over 2. So that becomes, we flip that, become 1 times 2 over 3. So let me just write the answer, 2 over 3 straight away. And then we time by this, f of x plus 1. So 3 over 2. So there you go, add as constant. Now I just simplify this. So to simplify this, that cancel with this. So limit 1 over 3. So the answer is a third, x squared 3 over 2 at a c. So that is the answer. But then we can write insert form since the question given in insert form. So I just write this down. So that give me 1 over 3. So if you think about it, x power 3 over 2 is same as x power 3 power half. Okay, power half is square root. Okay, so therefore this is the same as this. Plus 1 power 3 square root. And we add a constant c. Question 18. So first of all, we know that x is the average daily outside temperature. So this is x if you wish. Okay, so this is x. Let me just make note on this. And y is the total daily gas usage. So the total gas usage for 10 days is this. So that is y. Okay, the total y. So keep that in mind. And we know that x bar is the sample means. So that means we need to find the mean for this. Okay, and then the y bar and the y bar is the sample mean of the y value. So therefore we can find the y bar and x bar, and then we plot that on the graph. That's according to the question here. Okay, so to work out x bar, so therefore the mean of x, so x bar equal, and we know that the 10-day temperature is this. To work out the average, we just add them up and we divide it by 10. So let me just work that out. So I just go 0 plus 0 plus 0 is give me 0. And then 2 plus 5 is 7. Then we add another 7. And we add 8. We add 9. We add 9. We add 10. And with the 3 0 add is the same. Okay, so 50 and 10 score all together. So go 50 divided by 10. So that will give me 5. And to work out the y bar, so therefore y bar is equal to, so we know that 10 days, the gas usage was 1,840 megawatts. So y bar will give me, the average of that is 1840, and we divide this by 10. So the answer is 184. So therefore, the coordinate is 5 and 184. So there you go. So what we need to do, we need to plot this on the graph. So 5, 184, first of all. So 5 is here. So all the way to 184. So 180 here, go up by 2. 2, 4, 6, 8, 10. So there you go. So 184, 2, 4. So there you go. That is 5, 184. So now the next one is we need to plot the y-intercept. So for y-intercept, and we know that when x is 0, that is the 0 temperature, and the gas usage is this. So 0, 236. So where is 0, 236? So 236, so 230, 32, 34, and 36 here. Let me just clear it and redo this. So there you go. So that's it. So there you go. Okay, so part A done. Now part B, we need to find the equations of the regression line. And we know that y is mx plus b. And b is the y-intercept and already given in here. So when x is 0, y is this. So that is a y-intercept. So 236 is a y-intercept. 236. And to find the gradient, so we use gradient formula. So m is y2 minus y1 over x2 minus x1. And we have 2 points. So the first one is a y-intercept 0, 2, 3, 6. And the other point is we already found it here. So 5 and 184. Let me just write this down. 5 and 184. So what I do, I just plug that in a formula. So m is 236 minus 184 over 0 minus 5. That will give me, I just put on a calculator. So I just go fractions 236 minus 184, and then we go 0 minus 5. So there you go. If I put SD button, negative 10.4. So negative 10.4. That is the gradient. So therefore, the equations of the regression line, y is negative 10.4, x, and we add 236. So there you go. Or you can write 236 minus 10.4x. Okay. Now part C. In the context of data set, identify one problem with using the regression line to predict gas usage when the average outside temperature is 23 degrees. Now to work it out, first of all, we just work out the daily gas usage for 23 degrees Celsius first. That is when x is 23. So y is equal to, so negative 10.4 times 23 plus 236. So I just go negative 10.4 times 23 plus 236. So there you go, negative 3.2 megawatts. Since x equal to 23, y is equal to negative 3.2 megawatts. That means the daily gas usage is negative. So therefore, we cannot use 20 degrees Celsius to predict the daily gas usage. Okay, keep that in mind. So let me just write this down. There you go. Question 19. So before we sketch, let me just label x and y axis and the scale first. So this is 2, 4, 2, 4, negative 2, negative 4, negative 2, negative 4. So for this graph, so the x-intercept is when y equals 0. So when y equals 0, so this means 0 equal x minus 1. So x is 1. So x is 1 here. And the y-intercept is when x is 0. So when x is 0, f of 0 will give me negative 1. So negative 1 here. So let me just graph it. So just move close to the points. So there you go. So this is f of x. Now to draw g of x, so we know that x-intercept is 1 and negative 3. We'll just do a quick sketch. So negative 3 is here, 1 is here, same point. And then when x is 0, that means 3 times 1 or 1 times 3 is 3. So this is the y-intercept. And we know that because it's symmetrical, so the line of symmetry is between negative 3 and 1. So that means negative 1. This is the line of symmetry. And then we can find the turning point. You don't have to, but it's easier if just quickly find the turning point. So when x is negative 1, so g of negative 1 is 1 minus become plus 1, and then 3 minus 1. So that is 2 times 2, give me 4. So turning point is, so right here. So let me just quickly sketch it. And this side here. And just look at where we're going. So there you go. So that is a sketch. So now, next part, hints or otherwise, we need to solve this. Now to solve this, so this means that this line here must be below the parabola. So that's the answer here. Okay, we need to work it out. And we know that the point of intersection first is here and it could be here. So to work it out, we need to find the point of intersection first. To work it out, we just put two equations equal. So that means x minus 1 is equal to 1 minus x and then 3 plus x. Okay, and we just solve it so we can find the point of intersections for x coordinate. So we just expand this, give me 3, expand this, give me x, and expand this, give you minus 3x, and this give me negative x squared. So I just collect like terms. So x minus 1 equal 3, this give me negative 2x, and then minus x squared. And I move the negative x squared or everything on this side. So that will give me x squared, and these two move on this side. So that becomes plus 2x. So x plus 2x is 3x. And then the 3 move on this side, become negative 3, so minus 4. And then we just factorize it. So that will give me x plus 4, x minus 1 is 0. So therefore, x is negative 4 or x is 1. And this is 1 here, and this is 4 negative. So keep that in mind. So the answer, it should be, therefore, x is greater than negative 4 and less than 1. So that is the answer. So you can see the linear graph is below the parabola. So keep that in mind. And thank you so much for watching. Bye.